Number 2. Problem number 2. Look, it says algebraically. So they're doing the quadratic formula right there. And notice what they've done. They took the 16 to the left side of the equation, right? -9 minus 16 more is -25. They notice that there's a common factor of 5 between each one of these 3 terms. So you could divide everything by 5, including the 0. They don't even need the 5 right there. They could just divide the 5 to the other side. When is x squared minus 3x minus 5 equal to 0? They're plugging it into the quadratic formula. Opposite of b, plus or minus, you know, all that jazz. And if you don't have that down, you might want to put that in your memory bank, the quadratic formula. Now, I wanted to show you this. Like, after they simplify it, they get these 2 answers, right? Could you plug in exactly what you see right there into Desmos and just investigate, you know, what is the solution to our problem on Desmos? Because nothing says, oh, hey, you got to close your computer for problem number 2 because on problem 2 it says algebraically. You still have your computer open. You only can have Desmos open. I'm going to have, hopefully, GoGuardian working efficiently so you can't open up other things. But look, could you check your answer, 3 plus square root 29 over 2? I think we could, you know, 3 plus square root 29, and then a 2 right down here, 4.1 something, that's probably this guy right over here, right? Oh yeah, there it is right there. And then if I change this to a minus sign right here, I think I'm going to get my other answer right over here, boom, you know, because what's the line of symmetry? The line of symmetry is the 3 halves part, right? So if I put x equals 3 halves, here's the middle of the parabola. So if we go over to the right by the square root of 29 over 2, and we go to the left by the square root of 29 over 2, it's going to tell us what the 2 roots are, or the solutions to my equation, right? Another option would be to shift this guy down 16 spots. So we put minus 25 on there, and we find what the x-intercepts are, right? So now I don't care so much about this guy. I care about the x-intercepts, and I still get my same 2 answers, right? Oh man, I'm hoping to make this as clear as possible that there really could be a way that 100% of you could have the right answer over here. Now, does that mean 100% of us are going to get the right work? I hope so. I hope we can do the quadratic formula, and you know, you want it set equal to 0, though. It's not going to work if you just stick in 5, -15, and -9 into the quadratic formula. It's going to give you the wrong answers, okay? So make sure you're, you know, showing a little bit of work there. Okay, number 3. Let's take a look at number 3. Now, this is kind of interesting. They say algebraically, but they draw a little sketch over here. It might feel like, hey, that's got to be like incorrect. You can't do that if you're algebraically solving this. Well, look, we know it's a cubic function, right? So when we know for sure, give me a second here. When we know for sure that the, come on, pen. Look, let me see if I can get this on the screen here real quick. When we know for sure that the function is going down on the left and up on the right, like, you don't need Desmos to come up with a sketch. And you might say, well, somebody might plug it into Desmos and they don't pay attention to that information. Well, the person grading it isn't going to be able to tell. That's me. But I mean, I hope you know that kind of stuff. I hope you know cubic functions have end behavior like that. And then since, where is it down here? Here they are. The 3 factors all have a 1. I was going to say positive, we don't need to say that. They all have a 1 on them. That means it's crossing through, crossing through, crossing through at each one of the zeros, right? So, okay, why do I care about all this stuff? Why do I care about the graph? Well, isn't the y values right here, aren't the y values positive? And aren't the y values over here positive? So we want to report the intervals over which this stuff happens. Where does this stuff happen? It happens between -3 and -2. That's why they're saying that right there. Now, why are they putting the square brackets on it? Because we've got where is it? Right here. I'm going to go all the way down to this one. It's a greater than or equal to. So we'll take 0 too. It's 0, yeah, that's fine. And then over here it's 0, and it goes out that way. It's positive. So they're putting the interval down. Oh man, I hope I'm making this clear. I really want you to get 100% on the whole final exam, but definitely on the first page. All right, thanks for watching my video.